Let's solve this problem. Solve the differential equation 2x minus 3y dx plus 2y minus 3x dy equals 0. So this dE is actually an exact dE. Alternatively, this is also a homogeneous dE, but we will try to solve this differential equation using the process in solving exact dE. So how do we know if the given dE is exact? So given any differential equation of the form m of x comma y dx plus n of x comma y dy equals 0, so if the partial derivative of m with respect to y is equal to the partial derivative of n with respect to x, therefore, the dE is exact. And the general solution will be function f of x comma y equal to the constant c, wherein we can find this f of x comma y using two conditions. The first one, partial derivative of f with respect to x is equal to m of x comma y, and partial derivative of f with respect to y is equal to n of x comma y. So let's start solving this differential equation. So the first step is to identify the m of x comma y. It is the function being multiplied by differential dx, which is 2x minus 3y, and the n of x comma y, it is the function being multiplied by the differential dy, which is 2y minus 3x. Now let's test for exactness. Let's get the partial derivative of m with respect to y. So when we say partial derivative of m with respect to y, we will treat all the variable x as constant and we will differentiate all the variable y. So for the derivative of 2x first, since it's just a constant, its derivative is 0, minus, for the derivative of 3y, we will have 3, just copy since it's just a constant, times the derivative of y, which is 1. So 0 minus 3 times 1, it's just negative 3. Now let's try to find the partial derivative of n with respect to x. So when we say partial derivative of n with respect to x, it means that we will treat all the variable y as constant and differentiate all the variable x. So for the derivative of 2y minus 3x, for 2y, since it's just a constant, its derivative is 0, minus, for the derivative of 3x, we will have 3 times the derivative of x, which is 1. So we'll have 0 minus 3 times 1, or simply negative 3. So since the partial derivative of m with respect to y is equal to partial derivative of n with respect to x, which are both equal to negative 3, therefore the dE is really an exact dE. To solve for this dE, we will apply the two conditions. The first one is partial derivative of f with respect to x equals m of x comma y. So we will have partial derivative of f with respect to x equal to 2x minus 3y. Multiplying both sides by dx to separate df from dx, we will have, so for the left side, we can cancel out the dx, we will have df, and on the right side, we will multiply 2x minus 3y by dx. The next step is to integrate both sides of the equation. For the integral of df, that's equal to f, and on the right side, integral of 2x minus 3y with respect to x. So this time we will integrate with respect to x, meaning just like in partial derivatives, we will treat all the variable y as constant and integrate all the variable x. So we will integrate term by term. First, for the integral of 2x, we will have 2 times integral of x, applying power rule, that's x squared over 2. So we can cancel out this 2, we are left with x squared. Then minus integral of 3y. Take note that 3y is constant, so you can just put it in front of the integral times the integral of dx, which is equal to x. Then instead of putting plus c for the constant of integration, we will put a function of y, let's say t of y, for the constant of integration. So therefore, we will have f is equal to x squared minus 3xy plus t of y. Then applying the second condition, partial derivative of f with respect to y is equal to n of x comma y. So we will have partial derivative of f with respect to y. We will need to differentiate this obtained f so far with respect to y. So we will treat all the variable x as constant and differentiate all the variable y. So for the derivative of x squared, it's just a constant. So its derivative is 0 minus for 3xy. So this 3x is constant. So just copy. Then times the derivative of y, 1. Plus the derivative of t of y. Let's just put it as t prime of y. So we will have negative 3x plus t prime of y. And then we will equate this to n of x comma y. So we will have negative 3x plus t prime of y equal to n of x comma y going back. Its value is equal to 2y minus 3x. Notice that we can cancel out this negative 3x. So we are left with t prime of y equals 2y. So we can integrate both sides to obtain the value of t of y, or let's transform this t prime of y first in Leibniz notation. So it's the same as dt over dy equals 2y. Then cross multiply this dy here. So we will have dt is equal to 2y dy. We can integrate both sides. Integral of dt, that's t. Integral of 2y dy, applying power rule, that's 2y squared over 2. Or canceling out the 2, we will have y squared. Now that we have t of y equals y squared, we can substitute that in the value of f here. And we will use the general solution, f of x comma y equals c. So substituting f of x comma y, we will have x squared minus 3xy plus t of y equals c. And then substituting the value of t of y here, which is y squared, the final answer will be x squared minus 3xy plus t of y squared equals c. So this is the final answer. Okay, now it's your turn. So try to solve this differential equation and just comment your answers.